Hi guys, welcome back. Today we're going to do section 2.2 on quadratic functions. So a quadratic function is of the form y is equal to ax squared plus bx plus c. Okay, so it's going to be a second order polynomial, and it's going to end up making a parabola. So you're going to have two types. When a is greater than 0, in other words, when your lead coefficient is positive, you're going to get a parabola that opens upwards. So it looks something like this. Now it's going to have a couple of interesting things that I want to go ahead and point out. This point right here where it begins, where it starts, it's decreasing and then it begins to increase, that point of inflection is called the vertex. And this dotted line that would cut the parabola in half is called an axis of symmetry. Okay? Now, when a is less than 0, your parabola is just going to flip upside down. Okay, again, this dot, so it's increasing, and then remember right here it changes directions and begins to decrease. This again is called a vertex, and this is your axis of symmetry. Alright, so a couple more things we're going to talk about. We're going to talk about how to find the vertex. Okay? There's actually two ways. If it's in, it really depends on what form it's in. If it's already in its, if it looks something like this, the vertex is real easy to find. So if it's already factored, if it's already in this form, your vertex would just be the opposite of this number, 3, and this number, 2. Again, think back to shifting rules. Because this is contained in the function, it changes its sign where this one does exactly what you think. The problem is when it's in the standard form. So when I have something like x squared plus 3x plus 2, then to find the vertex I'm going to have to do something different. Okay? So let's go to the general form. If the general form is ax squared plus bx plus c, then to find the vertex, I'm going to take the opposite of b over 2 times a. So b would be your middle term, and a would be your coefficient of your first term. So that would give you the x value. To find the y value, you'll take whatever the x value is and plug it into this. Okay? Then find y by plugging in. And I'm going to walk you through some of these. So right now, don't panic. I know it's a little bit confusing, but I like to go ahead and give you the steps. Alright? So that's how you're going to find your vertex. I'm going to also ask you to find an axis of symmetry, the x-intercepts and the y-intercepts. Okay? So let's go ahead and walk through those, and then we'll hop into some examples. Alright, the axis of symmetry. You let x equal the x coordinate. You're just giving me the equation of that vertical line. And I'm going to go ahead, I'll put that in quotes for you. The x-intercept, okay, there can be no x-intercepts, there can be one x-intercept, or there can be two x-intercepts, is when you're going to let the function equal 0. The y-intercept you let x equal 0. So let's see how this is going to work. We're going to start off nice and simple. It's going to say graph each quadratic. And I'm going to ask you for all those pieces parts. Okay, so we're going to start off with f of x is equal to negative x minus 1 squared plus 4. Now, if we were to use our shifting rules, so think back for a minute. We're not going to. I'm going to walk you through it a different way. But you know the parent function is x squared. This flips it over the x-axis, moves it to the right 1, and then up 4. Alright, but let's go ahead and walk you through each part. First thing, find me the vertex. So when it's already in this form, things are great, because the vertex is just pick that value for your x, 1, comma, 4. Okay, so the vertex is a piece of cake. Now let's go ahead and do the axis of symmetry. So the axis of symmetry says let x equal the x coordinate. So looking at your vertex, what is your x coordinate? 1. So your equation is x equals 1. Alright. Next up, let's go ahead and find the x-intercept. And the rule says to let the function become 0. So this is your function. I'm going to let that become 0. Now you have options. You can, at this point, solve that by factoring. You can solve the quadratic a different method. You can do the quadratic formula. Alright, so I'm going to go ahead and just start, because this is going to square it, I'm going to try to isolate this term. So I'm going to subtract 4 from each side. So I get negative 4 is equal to negative x minus 1 quantity squared. Now I'm going to go ahead and divide by that negative 1. So that way I can get rid of that, and I get 4 is equal to x minus 1 squared. Now how do you get rid of a squared? Take a square root, and here's where some people make mistakes. The square root of 4 is positive or negative 2 is equal to x minus 1. And now I'm going to go ahead and separate it into 2. So I have positive 2 is equal to x minus 1, or I have negative 2 is equal to x minus 1. And now I'm going to go ahead and solve both of these. So x is equal to 3, or x is equal to negative 1. Alright, so far so good. Now the last thing I want you to do is find your y-intercept. Okay, the y-intercept is much easier. And I'm going to try to squeeze it here. So the y-intercept is to let x become 0. So go back to your function way back up here, and you're going to let that become 0. Okay, so I have negative 0 minus 1 squared plus 4. And now I work it out. So this is negative 1 squared plus 4. Negative 1 squared is 1. So the opposite of 1 plus 4 gives me 3. Alright, now we're ready to take all the information we have been given and let's graph. Alright, so first, the vertex. The vertex was at 1, 4. Next, the axis of symmetry is the vertical line that goes through the vertex. My x-intercepts are at 3 and negative 1. So let's see, we've graphed our vertex, we've graphed our x-intercepts, let's graph our y-intercept, which was at 3. And now I'm ready to go ahead and sketch in my parabola. Now, feel free to type it into your graphing calculator and verify it, but I want the work to support what we've just done. Alright? Okay, let's try another one. Okay, I'm going to do another one in the same format. So f of x is equal to x minus 2 squared plus 1. Alright, let's start off with A, find the vertex. And I think I did that in hot pink, so let me see if I can keep my color coding going. Alright, so the vertex is, change your sign, keep the sign. Let's do the axis of symmetry. X equals, and it's always equal to the coordinate, the x-coordinate of your vertex. Alright, let's do the hard one, the x-intercept. So to find the x-intercept, you let the function, you let f of x become 0, and now you're solving for x. So I like to do this by isolating my variable. So I'm going to go ahead and move the negative 1 over. So I get negative 1 is equal to x minus 2 quantity squared. And now I take the square root. And the square root of negative 1 is I. Which means right now I know that I have no x-intercept. That my roots are both imaginary. Okay, so anytime you try to take the square root and get an imaginary number, then you can stop and realize you have no x-intercept. Alright, let's try the y-intercept. Now it's possible that you would also not have a y-intercept. So to tell that, you're going to this time let the x value become 0 and then evaluate the function. So it's negative 2 quantity squared plus 1. So that is 4 plus 1 or 5. Alright, we're ready to take all our information and graph the parabola. So this time, and you can lag. So I'm hoping that it's figured out itself. I apologize. I'm not quite sure what's going on. So hopefully we can get this straight. But you can tell right here by the sign in front whether the parabola opens up or not. Alright, we ready? Alright, let's try one that's in standard form. So I have f of x is equal to x squared minus 2x minus 15. So this time I'm going to have to do a little bit of work to be able to get my vertex. So now I have to take that other option that says the vertex, to find the x-coordinate, I'm going to use the formula negative b over 2a. So look up here and tell me what's b. So b is this negative 2. I'm going to do negative of negative 2 over 2 times a. And what's a? A is the coefficient of your x squared term, which in this case is 1. And now I'm going to go ahead and clean this up. So I have 2 over 2, so my x-coordinate is 1. Now I'm going to find my y-coordinate. And to find the y-coordinate, you're going to take this x value. I apologize, can't see. There you go. I'm going to take this x value and I'm going to plug it into the function and see what the y value is. So I'm going to say 1 squared minus 2 times 1 minus 15. So I get 1 minus 2 minus 15. And so that gives me, what, negative 1 minus 15 is negative 16. So this is my vertex. Okay? So a lot of work when they're not in the other form for you to be able to get your vertex. Alright, let's continue. Now I need my axis of symmetry. You should be back on track. So the axis of symmetry is x equals the x-coordinate of your vertex, 1. Alright, let's do your x-intercept. So to find your x-intercept, we're going to let the function become 0. So 0 is equal to x squared minus 2x minus 15. Now at this point, you can either do the quadratic formula or you can factor it. So I'm going to go ahead and see if it'll factor. So my last term is negative, so I need 1 positive, 1 negative. I want things that multiply to give me 15 and subtract to give me negative 2. So if you need to come over here to the side, you need things that multiply to give you 15. 1 and 15, 3 and 5. So which one of those would subtract to give me 2? And it's the 3 and the 5. Now the only last decision you have to make is what gets which sign. I need a negative 2, so I'm going to let the 5 be negative and the 3 be positive. Now if factoring is still really bothering you guys, let's talk about that during Fluco time, because that's something that you need to really understand, but I just don't have time to teach you necessarily in class. Alright? Now go ahead and divide this into your two roots. So x plus 3 is 0, x minus 5 is 0. So x is negative 3, or x is 5. So there are my x-intercepts. Alright, last but not least, let's do the y-intercept. And if you remember, the y-intercept is to go back to the original function and to plug in zeros everywhere you have an x. And so I find that my y-intercept is at negative 15. And now I'm ready to go ahead and graph this one. Now I'm going to do my graphs by 2 this time because my vertex is all the way at negative 16. So 2, 4, 6. Actually, let me go by 4s, I think. So this is 4, negative 8, negative 12, negative 16. And this is 4, 8, 12. Alright, we said our vertex was at 1, negative 16. So 1, negative 16, way down here. My axis of symmetry is right here, x equals 1. My x-intercepts are at negative 3 and 5. And my y-intercept is right here. And now I'm just going to sketch in my parabola. And there it is. Okay? And so I'm going to pick up one more of these tomorrow in class with you, and I will see you then. Have a great evening.